In this experiment, we'll be looking at springs arranged in series and parallel, and we're going to do a combination as well. We need a retort stand. We also have slotted weights, each is 10 grams. And then we have a stick to hold multiple spring balances together. And of course, we have the spring balance. The spring balance is an instrument that is used to measure force. But the spring balance itself is made up of a spring inside of it. So this is perfect for this experiment. We are going to use the spring balance as a spring and a device to measure force. The slotted weight holder has a mass of 10 grams or 0.01 kilograms. And therefore the force exerted by this slotted weight holder will be its weight, which is equals to mg, which is equals to 0.01 times 9.81. And the value of the force is approximately 0.1 newtons. As you can see, the reading on the spring balance is almost 0.1 newtons. Once the force is removed, then the spring returns to its original shape and the reading on the spring balance is 0. In this experiment, we are going to use 50 grams of weights. The hanger itself is 10 grams and then we are going to add each slotted weight, which is 10 grams. So this is 20 grams in total. Add one more and we have 30. Another one and we have 40. And finally, with the last slotted weight, we have a total of 50 grams, which exerts a force of 0.05 times 9.81, which is approximately 0.5 newtons. When we apply the slotted weight to a single spring balance, we are applying a force of approximately 0.5 newtons. You can see the reading on the spring balance is 0.48 newtons. This may be due to an inaccuracy of the spring balance, or it may be that the slotted weights are not exactly 50 grams. But the important thing to note here is that the spring will bear the whole force exerted by the weight. We are going to use this stick to form a parallel arrangement of springs using the spring balances. And we are going to apply the same weight, that is 50 grams, to apply a force of 0.5 newtons onto this arrangement. From this arrangement, you can see that the reading on each spring balance is 0.24 newtons. That is 0.48 newtons shared equally between the two springs. In a parallel arrangement, the force is distributed equally to all the springs. When we add one spring balance to another, as shown, we have formed an arrangement of springs in series. And the first spring balance will show a reading of 0.4 newtons. This is actually the weight exerted by the second spring balance, which we will subtract from the readings later. Now we are going to add the 50 grams of weight or 0.5 newtons of force to this arrangement of springs in series. And when we look at the reading of the spring balance at the bottom, we will see that it gives the same reading as a single spring balance. That is 0.48 newtons of force. It is experiencing the full force of the weight. And if we look at the spring balance on the top, we have a reading of 0.88 newtons. And if we subtract the 0.4 newtons from the weight of the second spring balance, we know that the force exerted on this spring is also 0.48 newtons. We can see that for the arrangement of springs in series, each spring experiences the full force exerted by the weight. This is a combined arrangement of springs in parallel and in series. And as usual, at the first level, the spring balance will show a reading, in this case 0.2 newtons each. This is due to the force exerted by the spring balance below and will be subtracted from our readings later. We are going to use the same weight of 50 grams again. And when we look at the first level, that is the level at the bottom where there is only one spring, you can see that the force experienced by the spring is 0.48 newtons, which once again is the full force. It is as if it is a spring balance on its own. And then if we go up to the upper level, you can see that both the spring balance show a reading of approximately 0.44 newtons. When we subtract the 0.2 newtons due to the weight of the bottom spring balance, we get a force of 0.24 newtons. That is 0.48 newtons shared equally between the two again. When we have a combined arrangement of springs, we must look at each level separately as if it is an arrangement on its own. That's it for this video, guys. Thank you for watching until the end. If you found this video useful, please don't forget to hit the like button. Thank you very much for doing that. Do subscribe if you want to see more videos like this. I'll see you guys in the next video.